the sooner that we find essentially what causes aneurysms and why they rupture, the sooner we can stop them from forming and rupturing altogether. When we think of aging, chronological aging, we think of all our various body systems getting older, and that has a lot to do with cells themselves getting older. But what happens in high stress environments is that cells turn into old cells, senescent cells by themselves, even if you are not chronologically older. It could be stress from the things that we do in our lives. And so whether it's high blood pressure, smoking, sunlight damage, a whole variety of things, or another medical illness that causes a systemic stress to the body. Research in other fields showing that senescent cells, when they accumulate within tissue, they lead to dysfunction. They lead to things not working the correct way. That got me thinking, what role would those cells potentially play in aneurysm formation and rupture? I ended up receiving the grant last year. The main goal of my research endeavors recently has been to, first of all, see if we can identify senescent cells within the arteries of the brain, specifically within aneurysms. And then the next step is to see if we're able to reduce the amount of these older cells. Because of the support of the Brain Aneurysm Foundation, I was able to get some of that initial endeavor off the ground. The results combined from the projects over the last year is actually helping us sort of propel forward with higher level grant funding like our NR01. It took, the researchers at the BAF, the reviewers at the BAF, to realize that, hey, the science behind this makes sense and it's worthwhile to, support this kind of research. Because otherwise, I think that we'd go through a lot more years of trying to gather data or waiting for someone else to come out with more data to say, hey, let's look at this. Ultimately, I think that the people that will benefit most from this down the line will be patients, will be us, will be society.